Hello, welcome to the VitNerd, and today we're going to do a quick video on making a USB cable for power for certain Atari 8-bit computers. So let's get to it. USB power for Atari 8-bit computers. This will work on the Atari 600XL, 800XL, 65XE, 130XE, 800XE, and the XE game system, XEGS. They all use a 7-pin round DIN connector for power. They also use a 5-pin DIN connector for the monitor. So for this project, you definitely want to use a 7-pin DIN. You can get away with a 5-pin DIN. It will fit into the power, but it will also fit into your video port. So, you know, when your friend hooks it up for you, you never know. So you can get these parts easily. eBay, Amazon. I got these particular parts I'm using. Most of them I got from DigiKey a bit ago. I bought, I don't know, like 10 of each part to make a bunch of these cables. And the nice thing is, you can run this off any USB connector that has power in it. I've got a few here. I've got this Anker power. And then this is an old Apple iPad. This is another Anker. It's got 2 outputs. You can actually drive a couple computers off this. You can even use one of these. This one has 6 outputs. And this is actually an Anker. Well, by now you can tell I like Anker. Pretty good products. I recommend them. So this is USB power from a battery. Now, you need at least 1 amp output. Some of the Ataris, like the XE game system, if I remember correct, came with a 1 amp power supply because they figured people weren't going to hook much up to it other than plug in games and play games. But if you're going to be hooking up a FujiNet, some other peripheral devices that anything that doesn't have its own power supply is going to feed off the power from your Atari computer, and you need more amperage for that. So some of the original Atari power supplies were 1 amp, 1.5, 2 amp. So these all do at least 2.4 amp outputs from each port. I think one of these, maybe this one, because it's a different wireless charger capable adapter. I believe there's 3 amps on the output. So you might have some USB power adapters out there, maybe for an old Samsung phone, say, or something like that, that only has 0.5 amp, 3/4 of an amp output. Those aren't going to be good. So if you do this project and make this cable, don't ruin your experience by using the wrong power adapter. And you can look at any one of these should have the output right here on it. And this says 5 volt and 2.4 max output, 2.4 amp max output on each of these ports. And that's great. If you need more than 2.4 amps, then you probably know what you need at that point because you're hooking so much up to your Atari. Now, just to note, these will not work on the 3 original Atari 8-bits, the Atari 400, the Atari 800, and the Atari 1200XL. Those all used AC power adapters. So this will not work with those at all. The next thing, which I find quite interesting, is the SIO port on the Atari 8-bit computers, the serial I/O port, was kind of a predecessor, or is the predecessor, to the USB data connections, hooking up multiple devices to the same port, having them all work and cohabitate on that data line together. So it's kind of funny that the majority, the older, or the older, newer, which way does it go? The later models of the Atari computers, not only they all had the SIO port, but that the power's 5 volts, which became the standard power on the original USB ports, USB-A, these ports here that you see all the original USB-A ports. And so that's kind of funny that the Atari nailed it, that it's actually nowadays supports or was based around USB in a couple different ways now. So all you need is a USB-A male connector. Pigtail or not, you can get a cable, you can cut the end off. You've got to have some of these around the house. Everybody's got too many of these things. And then what else you need is a 7-pin DIN round connector. Now these might be a little harder to find around the house, but if you have an old Atari power supply, perhaps the ingot that you don't want, and you're going to get rid of the ingot, you're not going to rebuild it, put something else in the case, which is a cool project idea too. But if you're going to recycle that ingot, cut the end off for the 7-pin round DIN connector. And then you've got all the parts you need. So let's go ahead and this is one I've already made. Pretty self-explanatory. We're putting this on here with some duct tape and some solder, of course. So we're going to go ahead, and my particular cable, I need to cut off the end here. And I keep saying, and let's get some spacing on here, the length, because you're going to want to, at least for the connector I've got. Now, if you cut it off the end of, say, the ingot, you're going to be soldering onto wires. This I'm actually soldering onto the connector here, on the back side of it. And I'm going to clamp down this cable here. So I want to leave the coating on here, the cover. So I'm going to cut off about that much. And if you do this lightly enough, you don't want to cut through all the way and end up cutting off your wires. So let's see here. A little bit more. Whoa, thunder. Well, it's actually kind of a treat around here. This is, we're in Southern California, Orange County. And what's the old song? It never rains in Southern California. Well, it does rain sometimes, not enough in recent years, but just happen to have a storm going through right now. Mrs. Bittner loves the storms. I'm a Northeast born and raised boy, so I've seen plenty of rain, plenty, my fair share. So, but a lot of people out here just love it when it rains, not just because we need the water, but it's kind of rare. I don't think I've shot a video with a storm going on. Hopefully the lights don't go out. Okay, so this cable is a USB-A cable. And I've got a grounding, shielding wire here, which I'm going to save, because when I crimp that onto here, I'm just going to crimp that onto the metal. And 4 wires, because the original USB, again, I keep saying it, USB-A, was 4-pin. And you probably can't see it in here. I'll put a diagram up. There's 4 pins. 4 connectors, 4 wires, whatever you want to call it, say it. The outer 2 are power, and the inner 2 are data. Now, there's a standard for this, and that is that the red and black, or red and black, are the power, and the white and the green are for data. Now, if you know anything about standards, they aren't always followed. So if you open up your cable, and you've got different colors, or you're not sure that it followed the standard, you're going to want an ohm meter here, any kind of continuity tester, in order to check which ones are which. So I know on this one, because I bought a few of these cables, I've already made some of these cables, these are the data. We don't need them at all. We're just going to cut those off. And I want to strip off the red and the black. Now you can use wire strippers, But if you're delicate enough with a nice set of wire cutters, you can gently get that off. In my early years, starting as a teenager, I was just do this with my teeth, but I don't do that anymore. That's not good. So just to check here, let's show you how you can check. Gonna go ahead and put this on the black wire, which should be ground. And let's make sure this is working. Yep. So right here, you gotta watch out for the outer metal part. You can touch it, it's okay, but what you want is inside. And there we go. So in the orientation, I have this on, again, a USB-A male connector. On the upper part to the right is ground, and I'll put a diagram up for that. And of course, I'm not going to get any kind of continuity out of the other ones. And then let's just check the 5-volt, the positive side. Yep. And it's probably a good idea to check every one of your cables you're going to do this with, just in case there is a screwed up cable and then you waste all your time on that. Now that I've verified that, what I want to do is put the connector cover on this wire before I solder it. So don't forget that part, otherwise you're going to have to unsolder everything. So we're good with that. And if you take a look at the 7-pin DIN, and I've got another diagram up here for you. If you look, you've got 3 on this side, 1 down in the middle, and 3 on this side. Very symmetrical. Nothing on the top. And what this is all 3 on the right side, on the back side of this pin. These pins here, this goes into the computer. Let's take a look at the computer itself. This is just memory I've got plugged into the PBI. So again, the monitor has 5 pins, which is why you don't want to just grab a 5-pin cable. You probably have some of those. They're used for monitors, of course. They're used for MIDI. So you might have some MIDI extension cables if you're doing Atari ST stuff. But don't do it, because somebody can plug your power connector accidentally into your monitor. And that's why they're using the 7-pin on the power, because nothing else has 7 pins to accidentally plug it in. So over here, according to the diagram you're looking at, the 3 here are all 5 volts. It's all the same 5 volt. For whatever reason, Atari used the 7-pin and said, all the 3 on the right, if you're looking from the back, on the back side of the computer, we'll make them all 5 volt. They all go to the same point on the motherboard, and the 3 on the left are all ground for that. And 2 is for shielding or whatnot, or really nothing at all. So if we look at this, as it goes in, the same holds true on the back side of it where we're going to solder. So these 3 are going to be 5 volt, and these 3 are going to be ground. And you could just hook up one here for 5 volt and one for ground. You know, chances are 99.9% of the time will be fine. But the spec is that these 3 are 5 volt and these 3 are ground, so let's just go ahead and do that. We'll just throw extra solder on those areas. Whatever rig you have for holding down wires, cables. In the past, I've done things like just, put it, between 2 tools that are heavy enough to kind of hold it up for you. But it's nice if you've got some kind of clamp. Now, my particular connector here has holes. I'm just going to shove the ground wire on the correct side into one of the holes, grab some solder. Let's heat that up a little bit, let that flow on there nicely. Now, as I said, we're just gonna put some, lack of a better phrase, some glob of solder connecting all three of these ground pins. And you can't do this too long because you'll start heating up the metal too much, which will go to the plastic of the connector and start warping the pins out of place. Okay, there we go. Let's see. Okay, that's pretty good. Nice and clean. I'm just gonna spin this around. Do the same with the red. Okay, heat it up a little. And again, put some globs between the three pins, just connecting them all together. More glob is running downhill on me. I'm going to turn this around. Careful not to have any of that drip onto your skin. This is probably a pretty good beginner project if you're getting into soldering. You're not dealing with any discrete components. You're not going to fry any IC. It's not surface mount. Really just hacking a couple wires on the three pins, two sets of three pins. It looks pretty good. Let's go ahead and test this. Now, looking from the back, got 5-volt here and ground here. So if we turn it around, that's going to be the opposite. We're going to have 5-volt here and ground here. Okay, so we're done with the soldering portion. I'm going to go ahead and check this with a multimeter first. Okay, I'm putting this on the 5-volt side, which will be this pin. Perfect. And then the ground side. Perfect. Now, if you have a tester, you can use the multimeter, of course. In fact, let's just do that. I'm going to use, for convenience, this USB battery pack. No data, just power, 5 volts up to 2.4 amps. So now this is charged up. This is charged. This is active. And ground side here. And let's switch over. There we go. Make sure this particular battery, you have to click it on. It's not just auto on like a wall wart. And there we go, 5 volts. Okay, well, it checks out. Let's go ahead and let's put this together. Now, I'm not sure, of course, how yours is going to be. However, you're going to close this up, or maybe you pigtailed on to an old connector. There we go. So it is important to crimp that together because that's the cable relief. I'm going to slide the hood over. I like to lift this up a little bit so it goes over in case this slides back like that. Keeps it from coming off, especially when you're pulling it out of the computer. Okay, so we have, it's just a USB cable for power, but with a 7-pin DIN connector, which will go right into that Atari XEGS over there. So let's try that. This is original Atari power, and we can see we boots. Let's take that off. Just leave it there. Let's take our new cable, and you can make your own, and you can also find these on eBay, but it's fun making your own stuff. We're gonna plug it into USB power, portable power. So if I had an LCD screen for this, it could be on the road. Look at that.
Running your old Atari off a little battery pack. Wish we could do that 40 years ago. Conveniently, that is. So let's try some bug hunt. Okay. All working perfect. This is so easy when you're really close. Okay. Not so good. A little fun.
Okay, well, I hope you enjoyed that video, and comment below if you're going to make one of these, if you made one of these, how it's working out. And I'm doing a companion video to this as well, so check that. And what that is to kind of, well, kind of or exactly make the opposite cable going from 7-pin DIN to USB. And the use for that is you can grab one of these USB testers, and you can actually test your old Atari power supplies with this, or test your old your new USB power cable, or put this through with the cable and see how many amps your Atari is drawing. And there's the possibilities are limited, not endless, limited. But again, check for the other video, probably link somewhere here for that. So thanks again, thanks for watching, and thanks for supporting the channel. Ciao.